All right, well, there's nobody here right now, but I'm still going to go over the session. I hope you had a chance to look at the problems because these are definitely a little bit tougher than I anticipated. They are in the exact format and written by one of the people who generally helps out with that stuff. So I thought we'd go over this one. So there's first, we're going to start with some non-content information. Then I'm going to go over the practice FRQ, which I hope you've had a chance to look at. And like I said, it's a little bit more difficult, I think, than you may have anticipated. So hopefully you get a chance to look over this video. Okay, so here we go. So a couple things, AP Science testing words. These are a couple words you want to make sure you know. Brief explanation is going to be a short, maybe 2 sentences. Make it to the point. That's kind of what that means. You make these long and they start taking points off. A paragraph is something different though. A paragraph is 3 to 4 sentences. Go over every aspect of the answer, sometimes more than you think is necessary. And you just got to make sure you hit all of the pieces. If there are variables, you want to talk about all those variables in there. That's definitely what a paragraph means. Explicitly is another one of those keywords. It's usually combined with an equation, but you need to make sure you explain each step and why you did them. So that's a little bit different than the paragraph. Explicitly was going to be a big, definitely. I mean, both of them can be a combination of words and equations, but explicitly you have to be using words and equations and explaining why you did steps, just to make sure that you're clear on what happened here, why I did this, why I was able to do that. Even simple things like data coming from line, not the points, that should be stated in explicit style parts. All right, so official AP terms, and this is actually, you can actually find this, a little bit harder to find than I realized, but you can find it online. Calculate, perform mathematical steps to arrive at a final answer, include algebraic expressions, properly sustain numbers and correct labeling of units and significant figures. Also phrased as what is. So again, that's what calculate means. Compare, you've got to provide a description of explanation of similarities and or differences. Derive, perform a series of mathematical steps using equation or laws to arrive at a final answer. There's also describe, provide the relative characteristics of a specific topic. So that's important to understand. We've got determine, make a decision or arrive at a conclusion after reasoning, observations, or applying mathematical routines. So that's going to be determine. Evaluate, which means roughly calculate numerical quantities. And that's important to understand, roughly calculate. And if you go back to one of those videos, they talked about being able to substitute basically ones or zeros in for constants in a sense. And that's important to understand that you can do that. Lots of times equal then less than, sort of rank ordering is going to be your roughly doing, but you are going to want to show steps and calculations are not required. So when making these, you don't have to show the steps, but usually this is going to be a rank order question. Okay, these ones are a little bit smaller. We've got explain, provide information on how and why a relationship, pattern, position, situation, or outcome occurs using evidence. So that's sort of explain. You want to make sure definitely tell it how it happened, why does it require this. These are words you want to use on it. So that's an important word. Justify, again, you're gonna have to support why you did, defend your claim. And we talked about that with a lot of the test corrections. You have to defend why you think it's right. Label, provide labels indicating unit scale. Hopefully that's not going to be used as much on this one because you're not going to have to draw a diagram, but you would normally. These next two, you're definitely not going to have to worry about, but plot, sketch, draw. State, indicate, and circle, indicate and provide information about specific topic without elaboration or explanations. That's important to understand. So this is when you indicate or provide information about a topic without elaboration or explanation. You're demonstrating consistency between different types of representation. Labels may not be required. Sorry, no, that was what or would intercategory question. Sorry about that. Ooh, got stuff there. Verify, confirm the condition. So this is often the case if it was on one of the tests that we did that I did put that video out there. We had to verify this was the answer. So confirm that the conditions of the scientific definition, law, theorem, or test are met in order to explain why it applies to a given situation. So I'm gonna also go over now, obviously, how to make a quick reference guide. So realistically, what a quick reference guide is a longer cheat sheet. Okay, let's not get too carried away. It is basically a longer cheat sheet, but you're going to want to have one of these. And some of these are going to be skills that you might want to consider doing just to pay attention to stuff. How you doing, Hitesh? Can you hear me okay? Okay, cool. You can hear me. Excellent, excellent. So I'm just going over, this is on the quick reference guide. I am recording this just so you know. I'll have my chat thing up so you can sort of shoot messages if you can't talk. So again, the quick reference guide, I highly recommend you have these around when you're taking the test. So develop the quick reference guide by adding new items on quick reference guide following each of your notes. That is a way to develop discipline and review key points. That's something you want to do for future reference, but hopefully you've been keeping up with the notes that are on It's Learn, that are on YouTube. You want to basically sort of you want to do one for each of those would be a good thing. And it's not a whole page, obviously. It's probably going to be a quarter page or half a page. Write out quick reference guide by hand. You can get more in a document this way. If you have trouble reading your handwriting, then you can always type it, but you're definitely going to want to write it out by hand if you can. On quick reference guides, you're going to focus on mainly what is being covered in class or on that video. Things that your professor placed a lot of emphasis on. They've been really good about placing emphasis on things. At least I think they have been. Written down on the board or material that was discussed extensively, because they did go over a couple things multiple times. Should be on a quick reference guide. Let's see what else we have here. Things to include. So formulas that are not on your formula sheet. There are lots of formulas. Obviously, you need to have your formula sheet. If you don't have your formula sheet there, I don't know what to tell you. That's redonkulous. If you don't have a printer, see if you can find someone in your neighborhood who has a printer or someone who has a printer. You want to have your formula sheet printed out. I would not recommend writing that thing out. Hopefully you have a copy of it. I've tried to make sure everyone did. But you want formulas that are not on that sheet on your quick reference guide. So you might have quick reference guide, topics, and then you have equation quick reference guide. Example problems that are worked out, but the steps used in the problem list in order. You kind of want to write those steps out. That's always a good idea, because a lot of them are show step by step how to do something, and that can often be helpful. Reminder of things to look for in doing a problem. Any rules to solve a problem. So if there are rules, hey, this problem, I got to do this, I got to remember this. For instance, elastic collision, momentum and energy is conserved, but inelastic, kinetic energy is not conserved. So those are good to have. Symbols, because there are lots of symbols. Rules governing a scientific principle. Terms and definition, that's another one you're going to want to have. That's that thing I just gave you about the terms that I did early on in the video. You might want to take a look at those. This is a really good one, and you think it's not going to apply, but it is, because they're still going to be testing on the same material. Use old exams as guidelines for a quick reference guide. You'll know more of what teachers test on. There are a lot of teachers and a lot of people putting out questions. The only questions I'm going to be doing now are the ones that are put out by some of the test writers and other people, just like the one I have today. So make sure you're looking over those to see what things are worded, because it's definitely a little bit harder than I had realized some of the questions are going to be. Many of the AP videos have summary pages at the end. I know the guys do. He also had that summary pages like in conclusion. Those are going to be good things. Also, if you look at your textbook, now you're like, we don't have a textbook. Well, yeah, it's online and you have access to the whole textbook, but you can look at the end of each chapter, there's a summary of what's going on. And that's a good way also to make sure you've got the important information on there. All right, so before I go on, do you have any questions about what I went over? I'm about to go over the question. Have you had a chance to look at that question at all? All right, well, I'm going to go over this question. Like I said, this is a little bit harder than I thought it was at first. Took me a while to figure it out, which was not necessarily a good thing, but it is definitely one that's going to be a style of the format that you're going to have to be working with. So I'm going to read it out this time. A 10-kilogram object is constrained to move along the x-axis at time t equals 0. The object is at position x equals 0 and initially moving 4 meters. Oops, sorry. I haven't looked at the question, haven't solved it, but I want to go over the work. Okay, perfect. So at time t equals 0, the object is at position x equals 0, and that's going to be important that you realize that position is x equals 0. We'll get to that in a second. X equals 0, and initially moving 4 meters per second to the right. Its subsequent motion over 10 seconds is shown in the graph. The object is subject only to a conservative net force, so that the total energy of the object is 400 joules. So that's important to know. We're going to be dealing with energy, and the max you can have is 400. Explain how a graph of the potential energy function can be constructed from the given information. State 3 specific points on the potential energy graph and the shape of the curve connecting these points, and explain your reasoning. So first thing you need to remember about this sort of question is if you're doing a potential energy function, it's going to be potential energy versus distance. That's just the way it sort of is. That's what those are. You can look those up all you want, but that's what those are for those energy graphs. It's going to be basically a function of height or distance in this case. So that's what you want to make sure you realize. You need to pick 3 specific points. Now, obviously, you're going to pick the points from here. Now, you could have picked different points than I did, and I'm going to show you the points I picked. For instance, you could have picked this point right here because you're given the x distance, and you can obviously figure out the energy. I didn't pick that point, and I'll show why in a little bit. But you could have picked any different 3 points. I just picked 3, and then we're going to have to sort of describe how they were to do. Now, although you don't have to draw a graph, we're still going to complete this graph because you're going to have to sort of explain it. Because like it says, state 3 specific points on the potential energy graph, and the shape representing those points, connecting these points, and explain your reasoning. All right, so first thing we're gonna do is sort of go over, and here's the graph. And what I'm gonna do is I'm gonna start picking my points so that I can get basically the points on what the potential energy, wait, not the potential energy, potential energy function is gonna look like. So first point I'm gonna pick is there. Okay, so I've got my velocity at that point is 0. I picked that one. I think it's going to be kind of easy to deal with. I know that the total energy equals the potential energy plus the kinetic, because there's velocity, there has to be a kinetic. And I know that that has to equal 400, right? That's what it said. It's constrained to 400 joules. However, I know the kinetic energy here is 0. And if there's only these 2 types of energy, then my potential energy has to equal 400 joules. So there we go. So now I know the potential energy at this point. But again, a potential energy function is going to be energy versus distance in this case. So I now need to figure out the distance. Well, I'm given a velocity time graph. How can I find distance? I'm hoping you kind of realize that that distance is the area. So that distance is the area under the curve that gives you the distance. So that little highlighted circle. Hi, Sarah.
Hi.
So on this problem, you've got this highlighted area that we need to figure out the distance to get our area. So we have our energy, which is 400 joules. And again, we know that because the velocity is 0 at my first point I picked. And I'm going to find the distance because a function of a potential energy function graph is going to have distance on this axis here. So I need to figure out what is that distance. Okay, pretty simple. It's a triangle. Pretty sure 3 sides. Okay, good there. 1/2 base times height. Now, if you want to look, the base, not base or height, pick whichever one you want, doesn't really matter. There's 1, and that's 4. So it's 1 times 4, obviously divided by 2, you end up getting 2 meters. So now I have 2 points on my potential energy function graph. All right. Now, again, I could have picked different points. However, the next point I picked was this one. Okay, because I kind of picked it because I am going to pick the other point I'm going to pick up right now is here, but I wanted to pick 3 points that were close. And I needed to make sure I had a point on here that obviously would give me something other than a kinetic energy of 0, because that wouldn't give me a potential energy of other than 400, because that wouldn't give me any sort of shape to my graph. So I have to pick something else. So I picked that one right there. Now, same basic principle, energy equals U plus K, right? We know that kinetic energy is 1/2 mv squared. Hopefully you know that by now. It is on your equation sheet. Right here is my -8. That's going to be my velocity. So I have -8 squared, right? 10 times 1/2 is 320 joules. Now, that is not the number that is going to be one of the points on the potential energy function graph. I have to remember that my total energy is 400, so I got to subtract that 320, and boom, I have 80 joules. So that's my other point. So I have this second point, but I also need the distance. And again, the distance is still area under the triangle. But here's something, and this is actually where I made a mistake because I forgot about this point when I figured out my answer. You have to remember this piece because it's total area under the graph, right? So you had to include this piece right here. So I'm going to have to add that to whatever this is to get my new distance. So I'm picking this part of the triangle right here because that's the point right there. So if you look at it, it goes to, let me just go back here. It goes to 3. So 1 to 2 to 3 is 2. And it goes from 0 to -8. So that is going to be my actual thing. So right there is base times height, 2 times -8, 1/2, and I get -8. Now, originally, I thought that was my answer. It's not, right? I have to add it to 2. And now I have my next set of points, which is -6 meters because it's -8 and 2. And I have 80 joules. You remember from the question, though, it said it wanted 3 points. Now, I am going over this slowly and exhaustively to give you sort of how to solve this one. But you need to remember that, obviously, you need to be able to do this, and you don't have to write everything out so ridiculously exhaustively. So let's move on to our next point, and I'm going to pick this point here. 3 points. Boom. You could have picked this point up here and this point, I guess. I don't know. I picked these 2 points. Made it easier. Moving on. So E equals U, same thing, kinetic energy is 0, so I know my potential energy there is 400 joules because it has to be a total of 400, and I know my kinetic is 400. Same thing now with the area of the triangle. You still need to remember, you need to deal with this 2 meters. Now, there's a couple ways you could have dealt with this part. You could have added this triangle to this triangle, but for me, I thought it was just easier to get the area of the whole triangle. I'm still adding it to 2, but it's still base times height, and I'm not dealing with 2 sets of numbers in there. So I thought it was kind of easier to just figure out that whole triangle right there instead of putting the 2 triangles together. You get the exact same answer either way. So on this one, 1/2, and you kind of see here, it's 1, 2, 3, and it's still the 8 is the height, -8 is the height. So you end up getting -12. Again, that's not the answer because it's the total area underneath the graph. So you have to include that 2 right there. So I get 2 minus 12, and I get -10 meters. So now I have 3 points, and that's what it asked for. It asked for 3 points. You had to explain how you got them and explain about them. Now, if you want to look at what the graph looks like, it looks like this, right? This is my function graph of potential energy. There is my first point right there, 400 joules, 2 meters. We got that one. There is my second point, -6, 80 joules. We got that one. And there's the point we just did, which is -10 and 0. Now, is this the whole graph? No, it's not. It's not the whole graph. It didn't ask for the whole graph, though. It just asked for 3 points. Now, if I'd have picked another point that had the 0 joules, I would have had it, if I would have had it somewhere down this way or this way. The problem then would have been, and I'm not sure how they would have handled this because, this is uncharted territory. You would have had no shape to your graph. So you should have realized that you had to have a point that was not 0 joules to create some sort of shape on it. And these are the first 3 points. Yeah, I could have had the other point, which would have been 320 right here. 0 distance because it said it was 0 distance. So you could have done that point there. You still would have gotten a shape you could have used. But now let's go over the answers as they sort of look. Now, obviously, you would not include this in your answer because your answer should theoretically be able to be completely typed. Where is the question so I can look at it? I sent it to you on Remind yesterday, 2 different ways. I'm not sure if I sent it on It's Learning or not, but it is on Remind, and I'll go back to it in a second if you want. So just to go over this, the endpoints of the oscillation, because obviously this is oscillating, are where the velocity is 0, right? So the velocity is 0 at these endpoints because there's total potential energy. Taking the area of the velocity graph to where the velocity is 0 gives x equals +2 and x equals -10. And those are those 2 points. And it's talking about taking the area. So that's explaining again how you did it. Yes, I could have kind of used what I put on the screen, but it would have been very hard to write that or type that up. They want more words, more prose. That's exactly the word they kept using. The endpoint must be where all the energy is potential energy. U equals is that -400 joules? Sorry, that shouldn't be a -400. My apologies.
That should be a positive.
What?
That should be a +400. That's what I was saying.
You are correct. That's a typo. I apologize. U should be 400 joules at x equals +2 and x equals -10. So again, we're talking about that here. This is talking about having to take the area, well, obviously of the original, and then this is talking about this area is all 400 joules because there is no velocity. All right, the lower points on the potential energy graph, which is down here. Now it says lower points plural because there are more points. I only had to describe 3 points though. So the lower points of the potential energy graph is where the speed is the fastest, and it is the fastest, obviously, because the speed must have been 0 because on the graph it said it was 0. Where the speed is the fastest, taking the area of the velocity graph to where the velocity is the most positive or negative gives x equals -6 for the equilibrium. So again, equilibrium where everything is sort of balanced out. It's all would equal 400. So -6 was right here, and this is where you had both potential energy and kinetic energy, and added up it equaled 400 because it was 80 plus 320. So that's how you got the 400 there. And that's how you got that piece there. That was the second piece we did. So again, we're describing how we got these 2 points, taking the area. We're describing how we got this point, again, taking the area. Fastest speed is 8 meters per second. Greatest kinetic energy is 320, right? That's easy to figure out. The lowest potential energy was U equals 80 joules at x equals -6 meters per second. Okay. This actually I didn't put in there. This was put in by the person who provided the key. I don't think it's needed because it didn't ask for anything like that. The acceleration are constant. Now this is why they put it in, but I would have phrased it differently. The acceleration are constant, straight lines on the V versus T graph. So the forces, slopes of U versus X must also be constant. So endpoints at all equilibrium are connected by straight lines. Basically, I would have described this. I would have given the points. Basically, this thing, I would have given the points that we described, and then I would have said they are straight lines that goes from here to here, from here to here. And that's how I would have described that particular question. That's how I would have done this one. This to me is a little confusing, but I did want to put it on there because it is the way the test person wrote it. All right, now just hold on because I'm going to make this as a video, then I'll answer your question. So this Thursday, I mean Tuesday, Wednesday and Thursday, I'm doing AP1, but this Thursday I'm doing this question. I'm going to post it online. I will also let you guys join. This is an AP1, but it's also an APC question. So I'm going to let you have a chance at this one. I'm not going to go over it right now because I haven't given it to you, but you all have a chance at this one if you want. You can show up to the AP1 session because this is both topics actually, and so I will show that to you there.
Okay.